Okay. I couldn't help it. Welcome to a little new something there. Motivational, might fall down a little bit in Orgoland, but we will rise together. That yes, I'm here to help. Please ask me questions. It's chaos. It's Orgoland chaos, but I'm here to help. So please reach out. This video is part of that. So feel free to speed it up, slow it down, look at it a couple times. But let me be very clear what this video is all about. This video is an introduction into Beyond Labs, not the techniques that are going to be used in the synthesis of organic compounds using this virtual platform, but basically just a little brief tutorial on how to actually create an organic synthesis in Beyond Labs for our lab. Okay, if you want to know all about the techniques and all about the equipment and all the things on that lab bench and everything there, I highly recommend that you go to our appendix. And in the appendix, there is a page called something like Beyond Labs versus in Labs. That is a really cool page that'll compare the two ideas of our virtual Beyond Labs compared to what happens in the Wellesley College Orgoland. And you can see the similarities and differences. And what I really want to start off with is I want to give high praise to Beyond Labs because it is the first software that I have seen that actually mimics what takes place in an Orgo lab as close as possible, really from a virtual point of view. And it even allows you guys to make decisions about what you want to do. So I love programs that allow you to make the decisions. So what I want to do is show you a sample synthesis on how to actually create a synthesis. But again, if you want to know about what the glassware is for, what the techniques are used, please see our appendix in our Google site. Okay? So let's begin. Oh, I'll get rid of Mr. Bobblehead a little bit. Is he bothering you? Bye, Mr. Bobblehead. Oh, go away, Mr. Bobblehead. Okay. So let's begin with the assumption that you have already downloaded Beyond Labs and you have this Beyond Labs Connect as well. And you will need those to open up the following platform. So this is where you want to have on your laptop or your computer is you want to be able to access this page. This is the Virtual Chem Lab organic page. So don't go into the physics page or any of those others that Beyond Labs have. You want the organic one. And you can see there's a special list of synthesis versus qualitative. We're going to do the synthesis. And the worksheets down below here, on this side over here, these are where you can learn about techniques and play around. But ideally for us, we're going to go to nucleophilic substitution. So that's the first place we're going to go. That's the first reaction we're going to do. We're going to play around with some nucleophilic substitution reactions and see if you can predict if some of these reactions are SN1 or SN2. That would be really cool. You want to be able to go to the alkyl halide solvolysis section, 4.1. Open this section of Beyond Labs because it will contain the experiment we need to run today and in your own 3 experiments for Lab 4. Now, there is one little twist that I'd like you to do at this point. At this point, I'd love for you to upload into Beyond Labs right onto this screen here. I'd love for you to download, upload, create, have this Lab 4 nucleophilic sub template that you can see. It doesn't actually upload, it's just right there. It's a VLA extension that you've been asked to download to put on your desktop. This has little tweaks to the software throughout the Beyond Labs program that will allow me to put little tweaks in it that are specific for you and our lab. So please use this. And to use it at this point right now, you have to highlight and get back to the Virtual Chem Lab organic synthesis screen by clicking on it. And at this point, you want to hit Control-Shift-Q. It'll open up your window and allow you to open up any program, get to your desktop, like you can see my desktop here, and I can now open the .vla file that I've given you. Nothing magical will happen or look different. It's all internal, and some of it is just the way it's going to format your data at the end. Okay? Now we want to do a synthesis. Let's try a synthesis. Let's play with one. Let me show you how you can create one. And I don't want to do the same one you're going to do because that would be boring if I took your synthesis. So the one we're going to try is this one. Let's see if we can take benzyl chloride and see what happens when we react it with aqueous potassium hydroxide. Do we make benzyl alcohol and potassium chloride aqueous? So this is the experiment we can try. Before I even start this experiment, and what I would ask you to do and me to do is a couple things. One, ask myself, is this SN1 or SN2? Let's question ourselves before we have Beyond Labs do the experiment for us so that we can confirm that our guesses are correct. Okay? Two, please make sure that you actually calculate the molecular weights or molar masses for things like benzyl chloride and benzyl alcohol before doing the lab, because we are going to be able to take the mass spec and determine the mass spectrum of each of our reactant and our product. And as you can see, they should have different molecular weights. And so one of the things I want you to be able to do in Beyond Labs is not only do the experiment on the benchtop, but collect data off of Beyond Labs to prove to me that you actually did the experiment and the experiment actually worked and you actually produced benzyl alcohol. And the only way you can prove that to me, don't be liars out there, the only way you can prove it to me is by using IR and mass spec. So let's look at what Beyond Labs platform has. It has all those instruments over here. Okay, notice my cursor is now hovering over the FTIR, and that's where I can get my FTIR spectrum from. If I go just a little bit over, now it's hovering over the mass spectrum, mass spectrometer, excuse me. So I have my two favorite instruments in Orgoland sitting right here. You might wonder what all the rest of this stuff is. This one down here is for taking melting points of solids. In 211, Chem 211, we will not be making any solids, so this instrument won't be meaningful to us. This instrument, though, is very cool. That's called an NMR, otherwise known as a nuclear magnetic resonance imaging instrument, and you get to play with that in Chem 212. So hang on to Beyond Labs, because if you take Chem 212 remotely, we are going to use Beyond Labs to help you teach you about NMR, as well as do other cool, exciting synthesis reactions that are involved in the Chem 212 curriculum. So it's really cool. But for 211, we'll just put the brakes on and just play around with the FTIR and the mass spec. And occasionally, notice down here, our little old friend thin layer chromatography. That yes, I can follow the reaction sometimes using TLC. I can see where the spot is for benzyl chloride, and I can see if a new spot has appeared for benzyl alcohol. I could do that for this experiment, but I'm not, because we're not going to do that for the experiments that I've assigned for you. For you, we're going to go up here and play in the alkyl halide solvolysis section, and notice here are all the reactants listed right here. Here are all the reactants that you have accessible for this reaction that we can design. Our three experiments in lab are going to use the T-butyl chloride, otherwise known as 2-chloro-2-methyl-propane. It's going to use the 1-chlorobutane down there a little bit. And then there's a bonus reaction you guys can do with the 5-chlorobutane 1-all, that one with the alcohol and chloride, which is kind of fun. So you have two required mandatory ones for this lab, and I highly recommend you go ahead and play with the bonus one. Why not? They're really fun and cool. So the reason we will not use TLC for our reactants and our three experiments is because those molecules are very, very tiny. They're only like 4 carbons in size. And what happens with these molecules is as soon as you spot them onto a TLC plate and try to run it up the plate, the compound evaporates off. These 4 carbon molecules are only 1 carbon away from propane. Propane is a gas. So these will evaporate off. Okay? So let's go play with benzyl chloride and let's see and get a control of benzyl chloride. Let's see what benzyl chloride's IR and mass spec are. So to do that, you have to come over here. This is the stockroom area. And notice every time I get my cursor anywhere near one of these bottles, a syringe pops up. So the syringe is the universal collector to grab material out of a bottle and put it somewhere else. So it doesn't matter if it's a solid or a liquid. Beyond Labs is going to use the syringe as its tool of collection. So I'm going to hover my syringe over benzyl chloride. You can see the name and the structure on the board over there. So I hover it over there and I left click and hold. It grabs it. I have some in the syringe now. And now I have a round bottom flask on this stockroom countertop. And I want to put the little hand right on that red cap and let go. And boom, in goes the benzyl chloride. So now I have benzyl chloride in there that I'm ready to analyze. So I'm going to do an analysis of benzyl chloride like its IR and mass spec before I do its synthesis. So grab the flask, left click again, stick it into the ring stand, and notice now when I put my cursor over it, the compounds that are in that flask are no longer showing up on the blackboard, because it would be no joy if we did our synthesis and every compound just kept popping up on the blackboard. What fun is that? So no compounds in the blackboard when your flask is in the ring stand down there, okay? But that's okay, because I can come over and go to, say, the mass spectrum first, or the IR, doesn't matter. Grab the mass spec and left click on it, and it grabs and creates this little cute blue cap vial. And what I really like about this is these are the same vials that you guys are going to use in person. This is exactly what we use when we use our instrument for the mass spec in our in-person labs. So here we can just come over and lay it on top of our benzyl chloride solution, pure liquid, and let go of the left click, and boom, up pops the mass spec for benzyl chloride. How do I know it's benzyl chloride? Because I already did due diligence. I already looked up and figured out benzyl chloride's molar masses, and I knew that it had chloride in the 3-to-1 ratio, and I knew it should be at 126 and 128. So then I take my little cursor and I move it over the peaks, and it labels them for me. Notice there's 126, and it gives the relative abundance. You can ignore that. Like this one is 91 with like it's 95th percent. And just because it's the tallest peak does not make it the molecular weight. That's just a peak that loved to be made and fragmented off of my molecule the most. The heaviest pieces are my molecular weights. So I was expecting 126 and 128. So ideally what I'd love for you to do is go up here and even type in benzyl chloride so we don't get it confused with any other IRs that you're going to take throughout this lab. Label it here. And then, you know, you can grab it and it says save, but this saves it into the Beyond Labs lab notebook. I want you to save this in your Google document that you're sharing with me. So please use a snipping tool on PC or print screen and, you know, crop it using, you know, any other way to get this off of Beyond Labs into an image that you can then put in your Google Doc and share with me. And that's what we will do for all of our lab data we get off Beyond Labs. Okay? If you find an easier way of getting this information into a Google Doc, please let me know, because I've only done screenshots and snipping tool. It's kind of fussy, but I know no other way. if you really, there are like things you can zoom in. If you had doubted me that that's 126, you can click on the peak and get a closer look at it, right? And zoom in and then zoom out if you want. So please feel free to do that at any time. Beautiful mass spec of benzoyl chloride. Okay, now I have a control of benzoyl chloride's mass spec that I'll be able to compare to the mass spec of my product and see if it's changed. Okay, do the same thing with the IR, please. Grab and left click and you get a little pad. You put that pad over here on the flask of benzoyl chloride, let go, and boom, up pops the IR of benzoyl chloride. So again, type in its name because you're going to do an IR of the product. And when you put all these IRs into your Google Doc that you share with me, it's really important that we don't confuse them and that we know which one is which. And like any IR, like we did with the dual unknown lab, please make sure you fill out a complete data table with 3 columns telling me the experimental values, the literature values, and the bonds that are causing those values that actually prove that this came from benzoyl chloride. And notice there's no major functional group in benzoyl chloride. You cannot even see where the chloride is in this IR. We don't want you to. But notice when you make your product, something very drastically different should happen in your product's IR compared to this IR down here, right? So it'll be a way for you to compare. Cool. Okay. Now, I'm ready to do the experiment. I have to add all these other reagents, but the stockroom is closed. My diethyl ether is in there. What am I going to do? Oh, no. Okay, so the best part about this, anytime you make a mistake, like I've done for weeks in a row now, is that it's very easy to start fresh. So I'd like you to start fresh. To start fresh, you just go over to this waste container over here that says Clear Lab. What it looks like is a Sharpie's waste container that allows for syringes to go in there. But all you have to do is click on the white opening of that container, boom, and it clears the lab starting fresh. Okay, so let's start fresh. Let's go to our benzoyl chloride. Let's add the benzoyl chloride. Let's find our diethyl ether. That's what that little spider molecule is above the arrow. It's the solvent that this reaction is supposed to be in. And so diethyl ether is otherwise known as ether. And you can see the Et2O on the bottom. That's for ethyl, 2 ethyl groups attached to an oxygen. That's what's on my structure in the equation over there. So click, drag, put that into the bottle. And you can see that when you put the cursor over at this point, it is telling you what you have. And so please make sure that the blackboard shows exactly what you want in the flask at this point. Now again, just click and grab the flask, put it over in the ring stand, and I'm ready to add my aqueous KOH. Where is that aqueous KOH? It's down there somewhere. So you can just go over it. If you have great eyes, you'll spy it. It's just a bottle of KOH. Really, it is aqueous KOH in our situation here, okay? So left click, syringe pops up, put it so that, notice how the syringe is kind of jumping around. If you want to ensure that you get it into the bottle, very important here, that you make sure you put the little hand on top of the little red cap and then let go of the left mouse button and it is in the flask. But what's really important about this at this point is notice the blackboard is no longer telling me what's in the flask. So if you accidentally miss and don't get the KOH in your flask, you'll run your reaction without KOH and you might get horrible products, no benzyl alcohol. And the worst case thing is you get to come back and do this all over again. Another 15 minutes of your life. Okay, so now I'm ready to do synthesis on this, these reactants. And synthesis requires me to do a reflux reaction under nitrogen. This is a technique that, again, I want you to go look in the appendix for to see what reflux is all about and how it is going to be similar and different. But to do it in our experiment, you have to come over to the glassware section and grab the reflux condenser. This is the reflux condenser. There are two openings on the side. Those openings are to run cold water through to cool down the outer sleeve of the condenser so that any hot gases that are going up through the inner tube, which is completely separate from the outer tube, anything coming up in the inner tube will feel the cold water on the outer tube, condense, and fall back down into the flask. So once I put it on my flask, notice, boom, water tubing shows up so that I can pump cold water in here. Okay? At this point, it also says to heat the reaction, so I need to grab this cloth heating mantle and stick it under the round bottom flask. And last but not least, we need to do something that we don't do in our in-person labs because we just don't have all the pieces to do this with. It is grabbing nitrogen gas. And what we'd like to do is flush our entire system with nitrogen gas because we don't want any of the molecules from the air, like carbon dioxide or oxygen, to have a reaction with our molecules in the reaction. And sometimes that doesn't matter at all, which is why we don't necessarily have this in our Orgo teaching labs. But in research labs, this is often a must. So let's just default, and now we'll have great skills when you go do your Orgo research. You'll know how to put nitrogen gas in the top of your reflux apparatus to flush out the air and make sure this reaction has no air in it. This reaction now is all ready to go. Beyond Labs has put a little magnetic stir bar in the bottom of the flask for us already. So all I have to do is turn on this stir and the reaction begins. That also turns on the heating mantle and starts heating the reaction. And now, according to my reaction over there, it says to heat for 30 minutes. This little clock, excuse me, is telling you what time I start the reaction at. And yes, it is 5:30 right now where I am. So it is actually telling me the time of wherever you are on your computer. It's kind of cool. This could be 5:30 in the morning or 5:30 in the afternoon. Ooh, I don't know. What could that be? Okay, so sorry, I digress. So now we want to just change the time, speed up time, and make the reaction go 30 minutes. So you can do that. If I click this button here, this will automatically put 1 hour of time into my reaction. If I want 30 minutes, this adds 10 minutes, and this adds 1 minute. So I can click the 1 minute button 30 times, or the 10-minute button 3 times. 1, 2, 3. Woohoo! It's 6:04. Not really, but it is on Beyond Labs. It just went 30 minutes. My reaction has just completed 30 minutes of heating, and that's all the instructions said to use, that I should have produced my product in these 30 minutes. Now, I want to work up the reaction. Essentially, isolate the organic product or products, the benzyl alcohol here, or any unreacted benzyl chloride, and get it away from all the aqueous things, like any leftover aqueous KOH or any potassium chloride salts that I've made that are swimming around in the water. So now I have organic and water swimming here, and whenever you have organic and water swimming in the same pot, you do what's called an extraction. And extractions require the use of separatory funnels. Woohoo! They have one size here. In lab, you have all different sizes. Again, please look at the appendix to look up the details of what an extraction is and how to actually do one in a lab. For Beyond Labs, you take this over to the ring stand and you let it click on there and let go with your left click button, and boom, your product mixture is now sitting in the actual separatory funnel. Now, I have these workup reagents down here of water, sodium hydroxide, or aqueous HCl. You can use any of these that you want. I have KOH, so maybe I'll neutralize it with some HCl, and that'll get rid of it, but also basically generate an aqueous layer. And that's the most important part. I could have used water. And so notice when I go over here, if I want to make sure I get it in there, I have to make sure my hand's over the top of that sep funnel and then let go with the clicker, and boom, 2 layers. If you see real closely, 2 layers have now formed. there is an aqueous layer and now an organic layer that holds just my organic products. Water soluble or not, Beyond Labz will just separate the two and make sure that any organic compounds, even 4 carbons in size, will pop up into the organic layer and the aqueous layer will be down below. Not the same story when we're in a real lab, but that's the beauty of Beyond Labz. It makes things a little easier so that all I have to do now is click on the organic layer and put it down here in the cork ring. And my organic layer now is sitting here waiting for you to analyze it. You can do anything you want to it with the instruments over here. If you want, you can come over and take a carbon NMR of it. Grab that. Whoa, carbon NMR. I wonder what that's telling me. Okay, wait till Chem 212. All right, sorry. I got too excited. Let's just start with the IR. What are we looking for? You don't want to be surprised. So already have a suspicion, already guess where the absorptions are going to be for the product you want so that you can have a moment of glory, a moment of glee. I put the IR pad in there and I let go. Am I happy? Am I not? Is this what I wanted to see? This is what would be nice so that when you write product here, oops, sorry, I mistyped, but when you type in product and copy and paste this, you're already confident that you have made your product. And it just takes a little data table filled out to prove it to me in your Google Doc that you share with me. Okay? So do the same thing with the mass spec. You should already know what benzyl alcohol's mass is. You should come over and drop it into this round bottom flask and pop, up comes a bunch of peaks. You can zoom in on any of them, put your cursor over it, and ask yourself, is 108 what I was expecting or not? Zoom back out, and the one thing you can see automatically though is there's no 3-to-1 ratio of chloride in this mass spec. So maybe the synthesis did work. Okay? Cut and paste this. Again, label it products up at the top. Make sure it gets into your lab as proof that you did or didn't make the products that Beyond Labz was trying to do. And that's it. When you're done with this, you can hit the clear lab button and do the next experiment that you want. And notice this will take very little time. So it's not about how fast you can do the synthesis in Beyond Lab. It's trying to hypothesize what you think will happen for a reaction that I give you. What do you think is going to take place? And then using Beyond Labz to see if it actually takes place or not. And if you want to play around and use like this, where is it? This weird compound here and see what this compound would do, feel free to play around. And if you want to incorporate that and throw it into your Google Doc that you share with me, I don't mind if you show me other experiments that you played with. But make sure that you actually tell me before you do the lab what you hypothesized that weird compound to do and what did it actually do in your experiment. Okay? I hope this has been helpful. Should I put on the music again? I kind of like it. It was kind of inspirational.